Hi, in this video I'm going to talk about the standard normal distribution. The standard normal distribution is based on the normal distribution, but this is a standard version of the normal distribution. And what we are doing when we talk about standard normal distribution is also calculate areas of the standard normal distribution to be able to compute probabilities, to determine probabilities, okay? So in this first part, we're going to talk about the concepts and some characteristics of the standard normal distribution. The standard normal distribution, probability distribution, is the normal distribution generalized to any variable, regardless of the value. What we are doing with the standard normal probability is having, for example, height of people turning to a mean of 0 and a standard deviation of 1. We are getting like the test score of students and turning to a mean of 0 and a standard deviation of 1, and so on. We can get any variable and turn into a mean of 0 and a standard deviation of 1. Okay, this is what I'm talking about here. A variable having a normal distribution of a mean of 0 and a standard deviation of 1 is said to have a standard normal probability distribution. Okay, the standard normal probability distribution is characterized by letter Z. We use the Z like the Z-scores, and the standard normal probability distribution is the distribution of Z-scores. This is what the standard distribution is. Okay, is the distribution of Z-scores. This is the reason we use the letter Z to talk about the standard normal distribution. Okay, and remember, and I'm gonna show you too, but when we turn, for example, any variable, let's say mileage, tire mileage, into a z-score, the mean always becomes 0, and then we have positive and negative values. This is what I'm talking about in this slide. Negative values in the lower tail, left tail, which is below the mean of 0. They are below the mean, and positive z-scores, they are in the upper tail because they are above the mean. Okay, let me see if I have one applet here in Mind tab. Going to chapter 6 exploring statistics. Let's take a look at this. Explore z-scores of the normal distribution. This one is talking about useful, most common z-scores. Okay, but what I want to show you is that this is a standard normal distribution because the mean is 0 at the center, and then we have z-scores negative in this side, positive in this side. These are the most common and used z-scores, and again the standard normal distribution is a distribution of the z-scores. Okay, so this one could help to show you standard normal probability range, the z-score for normal distribution. Let's see if this applet can help illustrate. Yes, this one can help illustrate. Explore how a z-score provides a link between any normal distribution and the standard normal distribution. The graph below shows the normal distribution for the number of miles, x, that a car tire will last with a mean of 36,500 and a standard deviation of 5,000 miles. So we use this formula to turn any value, for example, from my car. Let's say I drove 20,000 miles. What is the z-score of my car, 20,000 miles? So I replace 20,000 miles in this x. 20,000 miles minus the mean, which means I below the mean. So the resulting number will be negative, and I divide it by the standard deviation, I get my z-score. And then I can plot the z-score in the normal distribution, which can turn into a standard normal distribution. So let's assume my car has 20,000 miles. So here's the miles, right? So 20,000 miles. Oh, I drove very little. Well, let's say I drive 30,000 miles. 20,000 is too few. 30,000 miles. So 30,000 miles. So let's say I drove 30,099 miles. Okay, so this is how much I drove, and this is the mean. So if I compute the z-score, I'm going to subtract 30,099 minus 36,500 and divide by 5,000, which is the standard deviation. My z-score is negative 1.28. Okay, so this is my z-score, and then let's imagine that I have another like figure in this zx, right? So I have another figure here. That would be the distribution, the standard normal distribution. So let's say someone like has a tire with 36,500 miles. So 36,500. It's 500. Okay. 588. Okay. So it's almost the mean. It's almost at the mean, right? Someone that drives 36,588 is almost at the mean. If I subtract 36,588 from 36,500, I'll get 88, and I divide it by the standard deviation of 5,000, I get a z-score of 0.02. This is the reason we say that the standard normal distribution has a mean of 0 and a standard deviation of 1, because we get the mean of any variable, in this case tire mileage, and we turn into z-scores. We have the standard normal distribution with the z at the center equal to 0, negative values to the left and positive values to the right. Okay, so this is to illustrate this concept of the standard normal distribution. In the next video, I'm going to show you some additional information for you to use to solve problems about that.